Assalamu alaikum, dear students. Welcome to your channel Mathematics Online. As you know, in the previous lecture, we have discussed the principles of mathematical induction, and we have illustrated the induction method with the help of example. Now we will go to exercise number 4.1. Here, in these questions, we are supposed to prove the following using the principle of mathematical induction for all n belonging to n natural numbers. So the first question here is, I have to prove that 1 plus 3 square plus dash and dash plus 3 raised power n minus 1 is equal to 3 raised power n minus 1 divided by 2. We have to prove that the sum of this series is equal to 3 raised power n minus 1 divided by 2. So how can we do that? Here we have the solution. You see, we have here this statement. We will write it like this. Let P of n be the statement, given statement. So we will first of all go to the basic step, that's for n equal to 1. For n equal to 1, we have P of 1 is equal to, it is 3 raised power 1 minus 1 divided by 2. If we see the right hand side, so it is 3 raised power 1 minus 1 divided by 2. It's 3 minus 1 divided by 2. It's 2 by 2. That's equal to 1. Yes, that is the first term of this statement. So we say that for n equal to 1, the statement is true. Next, let's see here. The next step of this is, we will now go to the inductive step. That is, we will suppose the result is true for n equal to k, and we will prove the result for n equal to k plus 1. So how can we do that? Let P of k be the statement, and where k is the positive integer, and we have this 1 plus 3 square plus dash and dash plus 3 raised power k minus 1, that's equal to 3 raised power k minus 1 divided by 2. We suppose this is true, and on the basis of this assumption, we will prove that the result is true for n is equal to k plus 1. So you see on the left hand side, we will go one step ahead. So it is like this: 1 plus 3 square plus dash and dash plus 3 raised power k minus 1 plus 3 raised power k plus 1, and this is minus 1, because we are going one step ahead. That is, this was up to the kth stage, and this is up to the k plus 1th stage. So we will arrange the terms like this. If you will see, this is 3 raised power k minus 1 and plus 1 and minus 1. This and this goes plus 1 and minus 1. You are left with 3 raised power k only. In the assumption, you know, this is equal to 1 plus 3 square up to 3 raised power k minus 1. This is equal to 3 raised power k minus 1 divided by 2. So you see, this is equal to 3 raised power k minus 1 divided by 2 plus 3 raised power k. Okay, we will now multiply this, making cross multiplication. This is 2 into 3 raised power k, and this is as such 3 raised power k minus 1 divided by 2. So it is now 2 into 3 raised power k, and it's 3 raised power k. You see, that is 3 times 3 raised power k, and this is minus 1. So it is 3 raised power k. So its base or same powers are added. It is 3 raised power k plus 1 minus 1 divided by 2. So you see in the basic result, it seems that we have just changed n by k plus 1. So you can see that the result is true for n equal to k plus 1 also. So if the result is true for n equal to k plus 1 also, by the principle of mathematical induction, we say that the result is true for all natural numbers. Okay. So on the same lines, we have other questions. This is 1 cube plus 2 cube plus 3 cube plus dash and dash plus n cube. Sum of cubes of first n natural numbers, that's equal to n into n plus 1 divided by 2 whole square. How can we prove that? For the proof of this question, we once again have to go to 2 steps. That's first of all, we go to the basic stuff for n equal to 1, and the next is inductive step. So for n equal to 1, the result is trivially true. Here it is. The calculations are here. And for the induction step, we will first of all make an assumption that result is true for n equal to k. So it's like this. If the result is true for n equal to k, on the basis of this assumption, we will prove the result is true for n equal to k plus 1. So we will go one step ahead, that's up to k plus 1th stage. So it's like this. So for up to kth stage, the sum is k into k plus 1 divided by 2 whole square. And this is k plus 1 whole cube. So we will make the simplification here and we will reach this stage. This is k plus 1 into k plus 1 divided by 2 whole square. Okay, so the result is true for k plus 1 also. And so we can say the result is true for all natural numbers. Okay. So these questions are all based on the same lines. And in these questions, you simply have to be very technical in arranging the terms at the last step. So rest, this chapter is based on only 2 steps. Let's see, we do one more question. Say, let's go to the next question. It is question number, say, we have here actually in this exercise, we have 24 questions. So we will be going to question number 12. So question number 12 is, prove the following by using the principle of mathematical induction for all n belonging to n. We have a geometric progression here, and we are supposed to prove the sum of this geometric progression is equal to a into r raised power n minus 1 divided by r minus 1. So how to prove this? We will prove the result for n equal to 1 first, and then we will go to the inductive step. So for n equal to 1, we have, this is the first term, that's a. So we have to prove that the right-hand side is also equal to a for n equal to 1. You see, the right-hand side is a into r raised power n minus 1 divided by r minus 1. So it is r raised power 1 minus 1 divided by r minus 1. So this and this goes, we're left with only a. Okay. Next, we go to the inductive step. For that, we'll make an assumption. So the assumption here is that result is true for n equal to k. And for n equal to k, here it is like this. We will prove this result for n equal to k plus 1. So for that, we will go one step ahead. You see here, we have step here, that is k plus 1th stage. Up to this stage, the result is by assumption a into r raised power r raised power k minus 1 divided by r minus 1, and this is a r raised power k. Making cross multiplication, we reach here, and the next step, making the simplification, these calculations. At the end, we are here, a r raised power k plus 1 minus 1 divided by r minus 1. So in the exercise, you see that it seems we have replaced n by k plus 1 on the left as well as on the right side. So the result is true for k plus 1 also. If the result is true for k plus 1 also, we say that the result is true for all natural numbers. Thank you for joining the class. Wish you all the best.